So I think a lot of presentations, they are trying to show you how to show the most relevant results. So what I want to show you here is actually the right way to show less relevant results. And I think this is really important problem if you want to improve actually user value and also increase business value. The results I'm going to show you actually are validated by 2 A/B tests and 1 offline evaluation. And just to give you a little bit of context, so a few months ago, I wanted to improve the user experience in vector search and hybrid search. And I think I was solving the wrong problem because I wanted to improve the embedding model. And at some point, I realized by looking at some examples that actually that's the wrong problem I want to solve right now. Because the lesson I will show you is that what I want to do is to show less relevant results and improve the user experience and business value. It might sound like a contradiction, but actually it is not if you think about the following. So users, if you have users not only care about getting the most relevant product, but they also want to products that are available. Imagine two products like A and B. A is the most relevant, but if you get it in 7 or 14 days, and the other one is not so relevant, but you get it in 1 day, there are a lot of people who will prefer actually the less relevant product, no? So now I will give you a way to actually, the right way we find to show less relevant product in vector search. So basically what we are doing is like embedding score, like cosine similarity, and then we might multiply with a product score, no? And this product score might contain information about like, is this product able or not? How popular is this product in terms of how often has it been sold in the last 14 days, 24, 1 month, and so on. When we did this kind of multiplication, we will have the precision at K, and I will show you in one plot, but it will increase availability. As a consequence, a year ago, more or less, we test this one, and it increased actually the add to cart and ECR, and it didn't take us like 1 month to find it out that this was the right way to go. But it took us like 2 weeks, and I think we could stop it in 1 week because the signals were so strong that this is better than just using cosine similarity. And a few weeks ago, we find a better way to show less relevant products. And the way we did this is basically, you still have the embedding score, but now you have a multiplication of the product score, but we have like f of beta, and beta is a parameter that we want to optimize. And beta can be between 0 and infinity. How do we find the right beta? So what we did, and I think on Wednesday there will be like even a workshop about that, is about we use LLM as a judge to optimize this beta. So here I have a plot where I'm showing you actually each points represent like a variant in an experiment we have. So here in this area, you can see basically the vector score, which is actually just using cosine similarity. And here in the y-axis, you have the precision at K. K in this case was actually 6. And here you have availability at K. And what you can see here is that the best actually precision, you get it with the vector cosine similarity, when you have only a vector cosine similarity. The worst precision is when we have what we call the control group. The control group was the control group in the experiment from this year. And here you have actually the cosine similarity times the product score. So what happens is that precision decreased, but availability increased. As a consequence, add to cart increased and ECR increased. So hurting actually precision was better. Now I told you actually there is a better way to do it. What is the better way to do it? So what we did, we ran every point are also simulations. So we simulate different actually search system with different betas. And we have here like variant 1, which was beta equals to 1. Variant 2 was beta equals to 3. Variant 3 was beta equals to 5. And what happens is the following. So here is actually an example of the query Roborock Reinigungsmittel, which is like a cleaning solution. So with vector score, you can see here the cleaning solution that you want. In the with the product rank, with the product score, you don't have actually the cleaning solution, but you have like products that that have a lot of margin and are available, no? And in this new area, it's like a new Pareto efficiency. What you have is actually high availability compared to the cosine similarity ranking, but also the precision increase. So what you will have in the top position is really relevant products and also available products. So what we did also, so this actually plot was from the first experiment. During the first experiment, I noticed that maybe these variants are not the best one. This one is the best one for the first experiment, but they are much better, and I don't want to be in a suboptimal solution. So what I plot is actually the beta as a function of the precision, and I ran several simulations, and what you can see here, when beta is equal to 0, you have the cosine similarity only as a score, and you have the best precision. As beta increase, the precision decrease. On the other hand, you have here availability as a function on beta, and what you can see is a non-linear function. And what is quite interesting, in the first actual experiment, these are my variants. I was actually not in the Pareto efficiency space, no? The best solution I can get here was actually the winner with experiment 1, was this one, which I could predict. If I had plotted this one before the experiment, I will knew this was going to win. Afterwards, when I did this plot, I said, actually, this will be my new variant 1 again, and I will actually also have these variants. And what happened in the second experiment is that the winner was basically where in this beta, which was beta equals to 54. So basically, it's like
quick time reminder. Sorry.
Sorry. Time left. So basically, what I wanted to tell you now, we could actually find the best. The lesson was like we use LLM as a judge to find the optimal symbiosis of vector search and product signals, and the results were consistent with the experiment results. And I didn't want to say actually who I was before I actually started because I didn't want to waste time. So this is my name is Abel Camacho. I work in Galaxus CH in Switzerland. Thank you very much.
Thank you.